Hi, geometry students. We're going to be doing, working with sets of numbers basically, and doing Venn diagrams. And so let's just get started with, I guess, reviewing what a Venn diagram is. You kind of see here, this is an example with three different circles here, three different ones. It says, in a birthday party, cakes, burgers, and hot dogs are served, and it is represented by this Venn diagram below. Okay, so Venn diagram is like a way of organizing data, and it kind of shows you, like in this case, who ate cake, okay, who ate burgers, who ate hot dogs, and who ate kind of both. You can kind of see where they all three of the circles intersect. That means they had all three. If you can see a number where just two of the circles intersect, that means they had just two of those, like cake and burgers, okay? So it's just a way of organizing information. So we can answer some of these questions on here, and then we'll get into like the more formal ways of writing what these look like. So this question here is, how many had hot dogs? Just in general, how many had hot dogs? So what you want to do is you want to look at the circle that has hot dogs, the whole circle, because everybody in this circle had hot dogs. So what you have to do is add up 10 plus 3 plus 2 plus 4. So 3 and 2, that makes 5. 5 plus 4 is 9. And 9 plus 10 is 19. So 19 people had hot dogs, okay? Even though, they're intersecting with other ones, you're supposed to just count everybody in the circle of the hot dog. How many had only cakes? So if you look at the cake circle, you can see some places where you've got an intersection with cakes and burgers. This is an intersection of cakes, burgers, and hot dogs. And then this is intersection of hot dog and cake. But they want only cake. So you actually have to look at this number over here. So that's just this area right here in the Venn diagram, which is 5. Okay, so this is how you read these things. How many had both cakes and burgers? So look at the intersection of where the cake circle and the burger circle intersect. So here's the cake circle here and the burger circle. Where they intersect is actually, these circles, if you can kind of tell, they intersect in this whole area right here. The 4 and the 2, okay? So apparently 6 people had both cakes and burgers, okay? So that's right there, we got 6 people. So you're gonna put a 6 down there. How many had hot dog and cake, but not burger? So now you have to kind of look back up here. Hot dog and cake, so you can see where these intersect, hot dog and cake. So it's really in this section right here, but then they said not burger. So it's just where the hot dog and cake intersect, not including the 2 people that had all 3. So you would just, right here, you would just be writing down the 3. 3 people had just cake and hot dog. Okay? So that number goes there. And then the very last one on this, how many had at least 2 items? At least 2. So what you have to do is think about, where in the diagram do you have at least 2? Well, it's where the circles intersect. Okay, because remember, the people here had hot dog and cake. People here had hot dog and burger. People here had cake and burger. And then the people here had all 3. So at least 2 would mean just give me the total of all of these right here added up, where all the intersections are. So 4 plus 4 is 8, plus 2 is 10, plus 3 more is 13. So that would be the intersections of all those. So 13 would be the total amount of people that had all, or at least 2 items, 2 or 3 items.